Hey everyone, I wanted to take a moment to do a walkthrough for Excel on section 6.1. So we've seen previously that we have an Excel sheet for the uniform distribution. In that same file, there's a tab for 6.1 and 6.2, and that's going to be for our normal distribution. And we have one sheet for both sections. They're very closely tied, obviously. So we know for normal distributions, we always need to know the mean and the standard deviation, right? So those are the first two things that you're going to put in. And what I show here is that I have 5 and 2 for my mean, but it could be anything. It could be 10 and 3. And notice that when I plug in my values for mu and sigma, my graph is going to change as well. These horizontal grid lines do not represent standard deviations. That's just Excel being Excel, so don't get too excited. I'd like to work an example using Excel just to kind of show you what it does. So let's see what's good here. All right, so a couple things that we can do. First of all, we can compute a z-score, right? So we know that if we're given a z-score, an X value, we would like to compute a z-score. So that's this first part right here. It says compute z-score and probability from X. So if I have, the first thing I need to do is I need to tell it what my mean and standard deviation are. So for this example, we had 30 was our mean. So I'm gonna type that here, 30, and then 6 was our standard deviation. So I have a graph of our bell curve now, which may or may not be helpful, but I do like to watch it squirm around a bit as I change mu and sigma. And I want to determine how many standard deviations away from the mean the value 20 is. So that means I want to convert 20 into a z-score. So all I do is I go to my X and I just type in 20. Lo and behold, it has produced the z-score in question. So it just will automatically compute the z-score for you. And so we see that we get negative 1.67. That's the same thing we got here in this example. There are these other two columns that are telling you something about probability. We're going to handle that in 6.2. So if you want to see that, watch the 6.2 lecture video for Excel, and it'll explain that. All right, let's do another example. So here we had, in this example I'm looking at, I've got mean 5 and mu is 5, mean, and then the standard deviation is 6. So great, now my PDF looks like this. It's gorgeous, I love it. And I want to convert 17. So when X is 17, all I do is I just go like, boop, 17, bing bong, boom, computation done. I got 2. I also got 2 here, right? So that's what we got when we worked it out by hand. When I wanted to compute 1, when X was 1, I wanted to know the z-score. So we're expecting to get negative 0.67, and we do. Okay, wonderful. So we also had this idea of finding the values associated with certain z-scores, right? That was like one of the last things that we did. Well, if we have a z-score and we want to know its X value, we go over here, compute X value from z-score. I would also like to add on the bottom left corner, it says compute z-score from X value. It's just the same thing right above it. If you were feeling overwhelmed with the probability columns and you just wanted some like visual zen, you can just do that here too. So like if you put in 17, 1, like totally fine. You totally do that. I could play around with this thing all day. If you want to compute an X value from a z-score, you can do that here too. So when we had this, we were like, oh, well, what range of values is going to give us that 68%? We have to know that 68% is associated to the z-score of 1. So if I wanted to do that, let's say I wanted to do the -1 and +1. I really need to change my parameters. So remember, when you're computing, you need to have the right mean and standard deviation. Okay, we had 172.36. This is for the Chilean heights. And then our standard deviation was 6.34. Okay, let's try that again. So I'm looking here on the bottom right corner of my Excel screen. So when I have z-scores of -1 and 1, that gives me the 68% that I need. And notice it pops out the x scores, the x values associated with those z-scores. So I've got 166.02 to 178.70, which is exactly what we got. And I can go ahead and I can do that for -2 and +2. And that is giving me $159.68 and $185.04. That is also what we got. This is so much faster. We could do it for -3 and +3. And so that's going to give me my range of values that are within 3 standard deviations. I need more colors. So I'd like to think that the Excel sheet is very useful. If we're doing a project and you need to create a graph of your distribution, guess what? Does it for you. Just tell it the mean and the standard deviation. If you need to compute probabilities, does that for you. If you need to compute a z-score, does that for you. If you need to compute an x value from a z-score, does that for you. I'm wondering what else. Oh, so here's another cool thing. Right, we just said, okay, I want the z-scores negative, like +and -1, +and -2, +and -3. And then I'm asking us this question all over again. Ugh, lame. But this time I have a different mean and a different sigma. I don't have to do anything other than just say, okay, this time do it with mean is 52, sigma is 11. Guess what? 41 to 63, boom, that was part A. 30 to 74, that was part B. 19 to 85, that was part C, and they're all right here. They're all still right there. It just gets computed with the whole thing. I wanted to say that there was something else I wanted to add. I think I'll just wait until 6.2. All right, so that's 6.1 on Excel. I hope you think it's helpful. You can download this file at the top of our lecture notes. You can download this file in myopenmath.com. If you have any questions, please send me an email.